Well, Impact is a leading producer of paper and packaging in South Africa, including recycling. So we have two businesses. The first is a paper packaging business, and the second is a plastic packaging business. In our plastics business, we produce a variety of bottles and closures, and also plastic bins and crates.
I think Impact has been recycling for over 40 years, primarily in paper, but we also are perhaps the largest maker of PET preforms in South Africa. And so it's a logical extension of our collection. We've well-established collection infrastructure for paper. It was logical to extend it into plastics. And then because we were already making preforms, we could form a part of our business would integrate into our own manufacturing. So PET was a logical progression from making from paper for us.
In South Africa, the current recycling rate of PET is around 50%, which means there's a 50% opportunity just on the current base of volume. If you add to that the fact that the use of PET in the country is increasing well above inflation and GDP, then there's no doubt that there's a huge opportunity to, one, improve the prospects for the environment, but two, there's a commercial opportunity for people who are able to recycle this, and we were able to exploit that opportunity, and that's why this size is really a reflection of the opportunity that exists in this market.
So the plant's split into sort of three distinct sections. The first one is the front end, which is really the sorting section. Then it's got the wash module and then the decontamination modules. So if you're talking through the individual processes, the sorting and front end section, the first thing we do is we take the bales and we feed it into a debaler, which then breaks the bottles up into individual bottles that spreads it across a conveyor belt nice and evenly. It then goes through a permanent magnet to remove any residual metals or baling wire that could be present in the product or the bales. From there it goes up into a conveyor to ballistic separators, and there's two of them on top of each other. The first one has got quite a coarse screen and the second one has got a more defined smaller screen, and the reason for that is to remove films and cardboard and other large components that should not go through to the next part of the process. But the smaller screen is there to remove dirt and dust and any loose particles that could be on the bottles that would fall through and then get rejected. The good bottles are then sent to another conveyor into the delabeler. And the delabeler consists of sort of two drums. The one on the outside is stationary with a lot of pins pointing to the inside, and the inside drum rotates with all sorts of guides on it, and the bottles are squashed between the two drums, and the rotation against the pins strips off the labels quite effectively. The bottles and the labels then drop off the end of the delabeler, and a air knife comes past and extracts the labels into a settling chamber. The labels are then disposed of separately, and all the good product or bottles then fall down onto the next conveyor and then go to the final stage, which is the electronic sorting or near infrared sorting. That we do in a series of 3 steps, and all we do there is you rely on the NIR cameras to identify the different product types, and we're only looking to accept clear or light blue PET. Anything else that is either not PET or a different color will then get rejected and rebaled, and then we send that out for reclassification and resorting off-site. All the good product then goes through into a manual sorting station, where any bottles that could have got through the electronic sorting that should not have been accepted gets removed, goes through a final metal detection stage, and then to the grinders where it's ground up into flake. From there, we then move across into the wash module. There's a break of a silo between the two systems because there's quite a lot of maintenance that needs to be done on the grinders. So to allow the plant to continue while the grinder blades are being changed, we have this buffer silo. The grinder flake then gets fed into the dry mixer where there's quite a lot of mechanical agitation with the product against each other. It then goes into a zigzag separator where any light fractions are removed, and we do that by introducing the mixture of product into the top of the zigzag separator. Air is then blown through from the bottom, counter current to the product falling down, and anything that's very light, whether it be thermoform films or sections of the bottle that is very light, gets extracted out. And the product that we want goes through the bottom and then to the pre-wash. The pre-wash we then is the first section of the plant where it sees water, and the flake then gets gently agitated with quite dirty water flowing over it. From there, the material goes into the intensive washers, and there we split it into two intensive washers because of the size of the throughput rate of the plant. The intensive washers then have quite a lot of flake at high temperature water with a certain amount of caustic in it, which does an aggressive and intensive wash to get all the surface dirt off the flakes. The flake is then recombined into one sink float tank. We introduce the water and the mixture of product into the middle of the sink float tank. Anything that is lighter than water and will float to the top, and that's predominantly the polyolefin caps. The PET then sinks to the bottom and is transferred using a screw conveyor to the post-wash rinser. That is exposed to very clean water at quite a high temperature, where we just polish the flake cleanliness, and finally coming out of the end of the post-washer is very clean, very pure flake that comes out at good quality. It goes to a mechanical dryer where it sort of gets flung around, all the water is centrifuged out. It goes into a thermal dryer, which is some tubes with some hot air just to get rid of the surface moisture. And then it goes into a final sorting station where we go through a series of metal detectors. It goes through a laser sorter and through a sieve to get rid of any of the small fines that could be present in the product, and that's the end of the wash module. The plant then goes into two decontamination modules, and there the process is split into half. The decontamination process, the first stage of that is where we take the flake and we gently heat it up using hot dehumidified air to a certain temperature to get rid of any surface moisture that could still be remaining, and to get it below a certain amount of parts per million in water for the next stage of the heating. We then go into two thermal screws, which are oil jacketed vessels, which then are used to heat the flake up with a lot of surface contact with the hot surfaces of the screws, and the flake then gets heated up to final process temperature. The second thermal screw, we do that in the presence of a nitrogen blanket to make sure that when it's above 160 degrees Celsius that we don't get any discoloration. The material is then transferred up to the top of the vacuum reactor, where it has to sit inside the reactor for a certain amount of time at a temperature with a very low vacuum level, so that any contaminants that could still be present in the flake is then extracted out, and the flake is then decontaminated or purified. The flake is then transferred out into a twin screw extruder where we melt it completely. It goes through a series of filter screens, through a standard underwater diphase pelletizing process. The pellets are then transferred to a crystallizer screen using water. The crystallizer screen is then controlled to make sure that we get the right amount of crystallization of pellets in individual form. It then goes into a de-aldehydization tower to get rid of any acetaldehyde that could have been reintroduced during the extrusion process. From there into final product cooling and into bag stations, where the final product is then weighed and checked and then put on hold until we do a final quality check on it, and then we then classify it dependent on the results that we get of the product.
For me, Krones is a company, and one of the reasons why we also considered Krones a good partner, that looks beyond just profit and looks to the long-term sustainable partnership and viability of the projects they undertake. And that was an attractive factor to us.
Well, we chose Krones because we thought that Krones had put more thought into designing a plant that was designed specifically for recycling, as opposed to a plant that had adapted other technologies for the purpose of recycling PT.
I think the Krones rPET technology has been developed and gives a superior product.
Thank you.